Maximum Transmission Unit, or MTU. Hey, everybody, welcome back to another episode of Tech Explained, where this week we're going to be talking about maximum transmission units. Now I know that sounds like we're in for a boring lecture about some dry networking concept, but trust me when I say that this one is super interesting, not just because it has real-world implications, but also because it has huge implications for gamers. So if you want to find out what an MTU is, stick around and let's get into it. Now, without getting too technical, the Maximum Transmission Unit, or MTU, is the largest amount of data that can be sent over the internet at one time by a single packet. Every message or piece of data that is sent over the internet is contained within something called a packet. It contains the data itself, some error-checking bits to make sure that the data wasn't corrupted in transit, and a header that contains all of the necessary information to deliver that packet, such as the source and destination IP addresses. The maximum size of these packets is determined by the MTU, which is the MTU of the network interface of the sender and the MTU of the network interface of the receiver. And the value of the MTU is actually quite large. By default, it is set to 1,500 bytes. However, it can be set to any value from 68 to 2048 bytes, with even numbers being preferred. So let's see how this works with an example. Let's say we have 3 people named Alice, Bob, and Carol who each have their own computers connected to the internet. And we want to send a file from Alice's computer to Bob's computer. This is where MTU comes into play. When Alice sends a packet of data to Bob, the maximum size of that packet is determined by the MTU of Alice's computer. In this case, the default MTU of 1,500 bytes. Now, once the packet reaches Alice's router, it will perform a process called fragmentation. During fragmentation, the router will break the larger packet into smaller packets, each with a maximum size of 1,500 bytes. These smaller packets are then sent over the internet to Bob's router. Once the packets reach Bob's router, it will perform the reverse process called reassembly. The router will take the smaller packets and reassemble them into the original larger packet. Finally, Bob's router will forward the reassembled packet to his computer where he can access the file that was sent by Alice. And that process happens billions of times every second for every connection on the internet. But there's more to the story than that. See, the problem is that the MTU isn't always the same across different networks. For example, many cable internet connections have an MTU of 1,500 bytes, while some DSL connections may have an MTU of 1492 bytes. Additionally, wireless connections such as Wi-Fi often have a smaller MTU than wired connections. And what happens when a packet gets too big? Well, it gets dropped. If the receiving device receives a packet that is larger than its MTU, it will simply drop the packet and send an CCNP message back to the sender indicating that the packet was too big. This process is known as packet fragmentation, and it can cause several problems. First of all, packet fragmentation can lead to increased network congestion. That's because when a packet gets dropped, the sender has to retransmit the data, which puts more load on the network. Additionally, packet fragmentation can lead to decreased network throughput. That's because the process of fragmentation and reassembly takes time and processing power, which reduces the amount of data that can be transferred over the network in a given amount of time. Finally, packet fragmentation can lead to increased latency. That's because the process of fragmentation and reassembly adds additional hops to the path that the data takes from the source to the destination. And each hop adds a small amount of delay to the overall transmission time. But wait, there's more. Even if the MTU of both the source and destination networks is the same, the MTU of the connection between them may not be. For example, if Alice and Bob are connected to different networks, then the MTU of the connection between their 2 routers may be less than the MTU of their individual network interfaces. In this case, even though Alice can send packets of up to 1,500 bytes on her local network, she can only send packets of up to the MTU of the connection between the 2 networks on the connection to Bob's network. This can happen when traversing multiple networks, and it's not uncommon for a connection to have an MTU of 1492 bytes. This can be problematic because it means that Alice would have to fragment her packets even if she were sending them within her own local network. To illustrate this point, let's imagine that Alice is trying to send a file to Bob that is exactly 1,500 bytes in size. She sends a packet containing the entire file to Bob. The packet arrives at the first router, which fragments the packet into two smaller packets, each with a maximum size of 1492 bytes. The two smaller packets are sent to the next router, which fragments them into four smaller packets, each with a maximum size of 1492 bytes. This process continues until the data reaches Bob's computer. As you can see, this can lead to a lot of overhead and inefficiency, and it can also cause problems such as increased network congestion, decreased throughput, and increased latency. But fortunately, there is a solution. There is a protocol called Internet Control Message Protocol, or ICMP, that allows devices to send messages to each other to determine the MTU of the connection between them. This process is known as Path MTU discovery, and it's actually an incredibly clever solution. Devices can use ICMP messages to probe the network and determine the MTU of the connection. When a device sends an ICMP message to another device, it includes a value called the don't fragment bit. This bit tells the receiving device to not fragment the packet that it receives. If the receiving device cannot accept the unfragmented packet, it will send back an ICMP message to the source device with an error code that indicates that the packet was too big. By sending out ICMP messages with different sizes, devices can determine the maximum size of packets that can be sent without fragmentation. Once the MTU is determined, devices can adjust the size of the packets they send to stay within the MTU of the connection. But why don't we just make MTU a variable that changes dynamically based on the network conditions? Well, we could do that, but it turns out that it's actually more efficient to just pick one fixed MTU and stick with it. The reason for this is that the process of changing the MTU dynamically takes time and processing power, which reduces the amount of data that can be transferred over the network in a given amount of time. Additionally, frequent changes in MTU can cause instability in the network connection. By picking one fixed MTU and sticking with it, we can avoid these problems and achieve a more stable and efficient connection. But what if we're trying to send a really large file? Well, in that case, we can use a technique called segmentation. Instead of sending one giant packet, we can break the file up into multiple smaller packets that each have a size equal to the MTU of the connection. This way, we can avoid fragmentation altogether and achieve higher throughput. Speaking of large files, did you know that it can take as long as 24 hours for your packages to arrive at your doorstep? I mean, seriously, sometimes it feels like we are reliving in the Stone Ages with how long it takes to get our packages. We ship millions of packages every year, and if we had to do it without ShipStation, we'd still be stuck in the dark ages. Seriously, it's so easy and saves us so much time every day. With ShipStation, you can easily compare rates from all major carriers, USPS, UPS, FedEx, DHL, and many more to find the best deal for every shipment. We've saved thousands of dollars since we started using it, and it just keeps getting better. You can also automate your shipping process by connecting ShipStation to your store, whether you use Shopify, WooCommerce, BigCommerce, or any other major platform. It literally integrates seamlessly. You can also connect to all of your favorite marketplaces like Amazon, eBay, and Etsy. Once you've connected your store, ShipStation will automatically pull in your orders, match them with your inventory, and let you quickly review and edit any details before finalizing your shipments. And the best part is you can do everything from anywhere. ShipStation has a mobile app available for iOS and Android devices, so you can manage your shipments on the go. Plus, ShipStation integrates with a ton of apps and services you already use like Zapier, Google Sheets, and more. Seriously, it's like having a personal assistant for your shipping needs. No joke. Thank you guys so much for watching. If you enjoyed this video, please leave a like down below and consider subscribing for more tech content. Until next time, I'll see you guys later.